Hey, what's going on, guys? So wanted to make a quick video talking about a variable resistor type of sensor. One of the main ones in a vehicle is a fuel level sender. So the way that this works is, so this sits in your fuel pump in the tank. When your fuel level goes high, or when your fuel level changes, the float will move. And the float is moving the contact across this resistor here. Excuse me. So let's take a look at what that does to our resistance. So it's a two pin circuit. Okay, so if you guys have heard of something called Ohm's law, I guess it does apply to us in the field and it doesn't at the same time. I don't really care about going too deep into like Ohm's law in specific, but we do know that as resistance goes up, your voltage and current go down. So here you can see at an empty fuel tank, we have 304 ohms of resistance. So on this circuit, you have a power and a ground. So when your resistance changes, your voltage will change going to the cluster and also to the PCM, and that's how it determines how much fuel is in the vehicle. So empty tank, because your float is all the way down, about 303, 304 ohms of resistance. And as you go up in your fuel level, you'll see your resistance changing here on the meter. A full tank is 16 ohms of resistance. So as your fuel gets lower, your resistance goes up. And in theory, that is supposed to change your voltage output that goes to the PCM. And that's the way that it determines how much fuel is in the tank. This is considered, like I said, a variable resistor. So it has many different resistance values. In the last video, we talked about a coolant temp sensor that also has variable resistance values. And then on a wiring diagram, a variable resistor would look like this. It'll have the squiggly lines, pretty much meaning that your resistance will change from the bottom to the top. Another example of a variable resistor is located inside of the throttle body. So yeah, if you guys haven't heard of Ohm's law, you guys can look it up. And there's a technical, by the book explanation of what it is. It doesn't really apply to us in the field as much, as long as you know, keep in mind that resistance does affect current flow and voltage. Another example of what resistance can do is if you have high resistance in a circuit for a light bulb, if the resistance is high in that circuit, then your light bulb will be dim because it's receiving less current flow. If you guys were dealing with a car that came into the shop, customer states fuel level is inaccurate, so that you would look up the shop manual and find out the specifications for the fuel level sender is for the resistance values, and then you would remove the pump and then do a full sweep like this, like how I'm doing. So 16 ohms at full tank, 302, 303 ohms at an empty tank, and then you would compare that to your specifications. Another possibility is somewhere along the sweep of the resistor, you could find a dead spot. It'll go open circuit or super high resistance, and that would tell you that the fuel level flow is bad. So there's a couple different scenarios of why we would replace the fuel level sending unit from it being inaccurate to not working at all. So let's see if we could find the specifications. So we would go to fuel system, fuel delivery. Fuel pump. Okay, so I found it right here. I don't know which vehicle it is, but depending on what cluster you have, analog versus digital, let's just say that, let me see if I could blow this up for you guys more. Let's just say that the vehicle you're working on is the analog type. So right here on empty, your specification of resistance is 298 ohms to 305. So like I said, the float sits like this. This would be empty because it's all the way down. As your fuel level goes up, the float will rise. So for empty, we're measuring 302 ohms of resistance, and our specification is 298 to 305 ohms. So we know that our fuel level sender is good as far as it goes to the empty part, and then you swing it all the way to the full, and we got 16.5 ohms. And then you would go to your full here, 14 to 16 ohms. So 16.5, I would still consider that good. Half a ohm is not bad at all. It's not much. And then a half tank would be 80 ohms. So I guess we would go about halfway. And based off of the ohms, this is about halfway here. And it is within spec. So we know that this fuel level sender is working good. If you found the bad one, then your resistance values will be either too high or too low. Then you would say, okay, let's replace the fuel level sender. And like I said, another test is to do a full sweep on the resistor and just go slow, and you might find a dead spot. So if right here it went to OL, that means open circuit. That's another reason to replace the resistor as well.